Hello friends, our today's problem is related to positional system. Positional system means we represent the number according to the position in which it has been placed. Suppose 2991. So our 2991 can be written as 2 into 1000 plus 9 into 100 plus 9 into 10 plus 1 into 10 power 0. That is basically 1. So here our numbers are represented on the position which they have been placed and based on the number which they have been multiplied. So our today's problem is we have to print all the 4-digit numbers in such a manner that their sum is equal in decimal, hexa and duodecimal notations. So suppose you have 2991. So 2991, the sum of all the numbers in 2991 is nothing but 2 plus 9 plus 9 plus 1. That is equal to 21. But if we write 2991 in duodecimal means we are having a base of 12. So in this thing we have base of 10. So every time we increase, every next number is multiplied by 10. So suppose 1 is multiplied by 1, then 9 is multiplied by 10, and then again here we are 9 again multiplied by 100. So you see every time we are incrementing it by a factor of 10. Similarly in duodecimal we increment the number by a factor of 12. So in duodecimal 991 is represented as 1893. That can be written as 1 into 728 plus 8 into 144 plus 9 into 12 plus 3. Here 3 is multiplied by 1, then if you multiply it by 12 and 144 and then 1728. 1728 is nothing but 2 cube, 144 is nothing but 12 cube, 144 is nothing but 12 square, 12 power 1 and 12 power 0. That's duodecimal. Similarly hexadecimal is when we have the base of 16. So let's see our sample input and sample output. We are not given any input, but we have to print a list of all the 4-digit numbers starting from 2991. Why are we starting from 2991? Because in other decimal systems such as hexadecimal and duodecimal, the 4-digit number starts from 2991. Sorry. So therefore we are starting from 2991 and then we are printing all the numbers. So what is our basic approach? So our basic approach is defining a function known as calc, in which we take the number which we have to find the sum of, and then the base to which we have to calculate. So in this function we will do nothing but first we'll have a variable sum. That sum will be equal to k percentage b. Here percentage does nothing but find the remainder. So suppose for 2991, if we divide it by 10, so our first remainder will be 1. So sum will be nothing but 1 plus second remainder will be 9 if we run it in a while loop, plus 9 plus 2. So basically we are getting the sum in the base which we require. If we replace this by 12 and then respectively we put the k, then we'll be getting our sum for whichever base we require, and then we will be finding our sum, and then we'll be equating if the sum in decimal place will be equals to hexa and the sum in hexadecimal should be equal to sum in duodecimal. So let us see some code for it. As you can see, we have initialized our calc, which is nothing but the function to calculate k, the sum of k when given in a base b. We have initialized sum to 0 and sum is equal to k percentage which we have described now, and then every time we do that we reduce k by b. Why? Because suppose we have 2991. You took the remainder and divided by 10 and took the remainder as 1. So this is the remainder. We took the remainder as 1. So like every time we need to for next remainder we need only 2991. So if we divide it by 10 in C programming, if it is an integer, will not be counting for 1. So this will become 299. And again we are taking remainder 9 and then again divided by 10, so we'll be only remaining with 29. And in similar manner we'll be able to obtain our sum. And then in the main function we defined our starting point, that is 2991, since 2992. Since 2991 sum is not equal in hexadecimal. Let me show you. So as you can see here, the sum of 2991 in decimal place is 21. In duodecimal is also 21, but when you calculate in an hexadecimal form you get it 36. So for 2991 should be rejected by our program. And then we take our starting point as 2992. Then we declare three variables, sum, h and d, for taking the sum in decimal, hexadecimal and duodecimal forms. And then we run a while loop for all 4 digits, and the highest 4 digit is 999. So while n is less than this, we'll be printing our sum. Then we calculate the sum for each of the numbers using our function, and then we check whether this condition is true. If it is true, we'll be returning the n number, and then we are incrementing it so that we'll check for another number. Thank you guys, this is all for today. Please be sure to like and subscribe.